it's my pleasure to introduce our next speaker, Dr. Gilson Regadas. Dr. Gilson is a leader at the Global Data Insights and Analytics at Cargill Digital Solutions. Dr. Gilson is a PhD in ruminant nutrition, and currently he's working as a project manager in some projects like Cargill Cattleville that he's going to present for us tonight. Prior to this role, Gilson was a consultant for Cargill Animal Nutrition, focused on supporting customers in the beef and dairy sector in data analytics. During his time, Gilson has developed several services for beef business in Brazil, including the largest benchmarking program in feedlot industry in Brazil, diet formulation software called NutriSmart, and flock growth projection models called Forecast. So Gilson has an extensive experience in developing digital services, products, and solutions for animal production industry, also working on digital product with different livestock species, including dairy cattle, swine, and beef cattle. So with no further delays, welcome Gilson, and thank you for being here with us tonight. So the floor is yours.
So thank you for the introduction, Marcio, and thank you for the invitation. It's a pleasure to be here. So let's jump directly to the subject of this discussion. So guys, I'm based in Brazil. I'm gonna present to you a project that is currently being developed in Brazil, named Cargill Cattleville. Cargill Cattleville, it's a co-development between Cargill in malnutrition and Casco. Casco, it is a startup company based in Brazil, and we worked together in the last 3 years to develop this product, and last year we launched that in the Brazilian markets, and now we are in the phase of grow the business and grow the number of customers and improve the product as we grow it. Okay, so I'm gonna follow this agenda. I'm gonna try to explain the problem we are trying to solve, and then I'm gonna explain how CCV, Cargill Cattleville, works. I'm gonna try to demo you briefly the platform itself, it's possible, and then I'm gonna share with you guys one video down to the market, to the beef producers in Brazil. So probably you know that more than me, but one of the biggest challenge that we have in large feedlots is to properly manage the amount of feed to offer to the cattle on a daily basis. This is what we call the feed bank management. And in order to calculate that, the feed manager must know obviously the number of cows in each pen, the number of animals in each pen. They need to know the bunker reading activity that's at stake on a daily basis. They need to have a good idea of the weight of the animals. The intake proof that help the feed manager to decide if they will increase or decrease the amount of feed to be offered to the animals. Also, the animal behavior is also a very important topic to decide and to make the calls, and also if there was an events like rains or any feed delivery issue that affected the intake of the animal in the previous day. Among other important information that this guy needs to know before to make the call if they increase or decrease the amount of feed for each pen individually. Okay, so this is a big problem in big feedlots, but also in the smallest ones. For example, in a feedlot like this is one of the biggest feedlots in Brazil, capacity of 75,000 animals, and they run 2 cycles a year. They have 500 pens, and more than 50 miles of bunker to read in a daily basis. They use different methods. Sometimes they use motorcycles. There are feedlots that use horses, and I don't think that's going to be different in the US or Canada. And it's really complex, to read the bunker for all the pens, and then go to the office, analyze the data, analyze the behavior of that pen, the feed intake curve of that pen, and then make the decision, and then feed the animals in the same day. And this is a process that happens on a daily basis. So the Cattleville aims to try to solve this problem, or at least to help the producers to be more agile when make these calls, okay? So the project aims to use photos taken from drones and processed through machine vision to generate various insights for feedlots. We have divided the project in 3 waves. The first wave deployed on June of 2021 when we started the pilots, had 5 features, the main features. We were able to count in the standing and lying animals, what we call inventory of the animals, the product. We are counting animals near to the water trough, so in order to identify if there is any issue with the water, we also developed in this phase index named Cargill Welfare Index, and I'm going to try to explain this index later in the presentation. And as our previously speakers, we tried to develop a model to predict the average weight of each pen. Actually, we developed this model, but when we implement this model using picture from 50 meters high, then the accuracy decrease, but from 3 meters high, we have a very good accuracy, and I agree with the previous presentation. It's totally possible to predict the weight of the animals by using images. And then after that, we started the pilots, and then we started the second wave of development, and the goal was to integrate the CCV with the herd management softwares in Brazil. We have 2 in the Brazilian markets, and that's done. And then last week, I'm pleased to say to you guys that we deployed what we call the feed bank management feature, where we allow the producers really try to read the bunker and make the call from the office without have to go to the field, without have to go to the field, read the bunker. And then we hope this year start the third wave of the product that we automatic decision-making process through machine learning models. We intend to embed the forecast model. The forecast model is a model that is used by Cargill in North America and also in Brazil, project the growth of each flock or each pen, and also to implement the optimal slaughtering points for each pen and help the producers to make better decisions. So how CCV works? So it's pretty simple. I'll try to explain here, but first of all, we preset a flight plan in a mobile app. After that, the user select the flight plan and click go. After that, the drone flies alone automatically over 100 pens, and it takes 20 minutes. This constraint is due the battery life, We are using a commercial drone for these operations, but we are also analyzing to use, some specific drones with more autonomy or bigger feedlots, But even with this current drone, we are able to land the drone, exchange the battery, and then fly again and cover the rest of the pens. After that, after the flight, the drone lands automatically at the same place where it starts the flies. The user removes the memory card and upload the photos on the CCV. It's pretty simple. With 2 days of training, all the users were able to manage the drone. So this is not something that really takes time, or it requires a lot of complexity. So now with more details, let's assume that we have a hall with a few pens. Then the drones start the flight here. They flies over the pens, and they take individual pictures from each pen, from the top of each pen. Then it lands. We upload the image into the platform. The AI process the pictures, and then we provide a few insights to the users and help them in the decision-making process. This is how the process works today. Here, a few photos from the drone. This is the whole picture, exactly as is taken from the drone. It's possible to see that we also cover part of the next pen, but we have developed something to trim just the area of the pen, okay? And then we trim the eye of the pen. We use the fancy of the pen to trim just the pen, so we can count the animals inside the pen. After this pre-processing that happens, we start to count the animals and classify the animals. We classify the animals as standing animals and lying animals. Okay. In green, we have, in this specific picture, we have in green standing animals and in red lying animals. But in the platform, you see that the color is the opposite. In terms of accuracy, our accuracy to count cattle is more than 99%. Accuracy classify standing and lying animal it's about 90%. Accuracy to trimming the pen, it's 99%, you know. And accuracy to find the water trough, it's 9%. And we hope to improve this accuracy as we add more pictures, more data to our AI. Let's jump to the Cargill Welfare Index. This is a KPI that is meant to indicate how nervous the cattle are before being fed. And it calculates this by considering several factors, such as the number of animals standing near to the bunker before they are fed, you know. Here we have two pictures from the same pen, from the same group of animals. The difference of 2 days, yeah, this is from October 27 and this is from October 30. 3 days difference, pretty much the same hour, 7:15, 7:30. And it's easy to see the difference in the behavior of the animals. Here we see how the animals are lying. They are calm, they are not waiting to be fed, you know. So this is the behavior that you like to see in a pen before the pen is fed. Here, it's a little bit different, the behavior. You see how the animals stand, most of the animals standing, you know. Sometimes we see the animals close to the bunker, accumulate in this region here. This region is the first region where we deliver the feed. The truck always come from this direction here. So, and then we use the location of the cattle in the pen, and also if they are standing or lying, if they are close to the water trough, to develop this Cargill Welfare Index. You have different, and this index starts in 0 and goes to 10. This is the range of the KPI. In this case, we have a Cargill Welfare Index of 9.9 and here 7.5. Here I have more details. This is a real Cargill Welfare Index curve from the entire period of the animals in the feedlot, you know. And here we see the variation. We have some peaks and some valleys. And when we have this valley, for example, it's easy to see that our animals are standing close to the bunker, waiting to be fed, you know. They are nervous. And here the other day, they are very calm, you know. There is a variation in the behavior of the animals throughout the period of the confinement. And we are using that to adjust the feed to be offered to the animals. Here a few more pictures just to give you a taste of what we have in the platform. This is a regular pen before the picture is processed, and this is after the picture is processed. And it was funny because during the pilots we proved something that we used to hear, you know, that one picture is worth 1,000 of words, in this case 1,000 of AIs, because despite all the index that we are creating through artificial intelligence, the users are also using the tool to identify other issues that were not covered by AI. For example, if we have issues in the water trough, if we are, for example, losing water here, if we have rolls in the pen, if we have problems in the fence, you know, if we have rolls in this area here, if we have problems in the bunker, there are other problems that they were able to identify just because they have the picture of the pen every single day. Here another picture, but what I would like to show you guys, yeah, in this case, sometimes we fail. As I said to you, we have 99% of accuracy, but there are a few fails yet. We hope to improve that as we move forward. But what I would like to demo to you guys is the platform itself. Let me quick open that here. This is the user interface of the platform. We have the feedlot here, how the pens are mapped. through GPS, and then after the flight we have these warnings by pen. So I know that this is the list of warning from today. This is a flight from today that took place at 7:40 in the morning. The overall Cargill welfare index for this feedlot is almost 10. It's a very good feedlot in Brazil. We have 4,000 animals, 4,101 animals. This feedlot today. Actually, it's not in the whole feedlot. We are just flying half of the feedlot, so it's not really the total number of the animals. In this case, we are not flying in this area here of the feedlot because of the autonomy. But I can, let me tweak them that to you guys. Let me enter in this pen here specifically. I see the picture from today, and I can, it's in Portuguese, sorry guys, but I can click on here, and then I jump to what we call, pen analysis, where we see everything related to that specific pen. So like the breed of the animal, the days on feeds of the animal, the number of animals in that pen, the initial weights of that pen. And here, this is the place where the users make the calls on the feed offer, okay? Here they take a look on the picture, they see the behavior of the animals, how the animals are, and it's easy to see that there are a lot of feeds in the bunker in the morning, feed from yesterday, from yesterday. So, and we also developed this other image here, where we try to put the bunker in a way that easier to the users to take decision. So we split the bunker in 5 segments, and then we create this mosaic so they can read the bunker direct from the picture. And this is something that is done by the AI. The AI trim the bunker and then create this mosaic. So today we are still making the call manually. We make the call here if we increase or decrease the amount of feed. But in the future, we intend to have an AI actually making the call and suggesting to the producers what they must do or what they should do, and it's going to be up to them to accept or not. Here we are able to see the Cargill welfare index and the night readings. In this case, they used to do 3 night readings, 8 p.m., 10 p.m., and 2 a.m. to check if there is feed or not in the bunker, and then they make the call. They make the call for tomorrow, or for today. Actually, this is something that they used to do during the morning, and the call is done for today. This is what was the adjustment that was done for today. So in this case, it's funny because we are counting in the herd management software. There are 92 animals, but in the field there are actually 87 animals. So there are 5 animals less in the physical, in the pen, and probably this is the reason why we are so much feed left in the bunker during the morning. So, and this is the reason. This is the goal of the tool. Help the users to make the better decision. Guys, I'm not going into details here. If you have any interest, you can send me an email, and I can arrange a more deeply demo to you. What I'd like to share with you now, guys, it's a video. Let me open that here. We have subtitles. Guys, thank you very much for your attention. And this is it. If you have any questions, please let me know in the chat.